specifically talk about manufacturing, the CIA triads actually gets changes to AIC triads, where the availability component take way more priority than confidentiality, because manufacturers are in a business of manufacturing products, and they want their machinery, their components to run throughout day and night, and they do not want that to get impacted. So one of the key challenges on the cybersecurity side is obviously the ransomware, because it directly hits the availability concern. The second part with regard to manufacturing is what we call it as the espionage, where the adversaries are looking for their intellectual property, their recipes, their key recipes that they have. We have work on investigations where we see theft of intellectual property, and the adversaries sell that to competitors, and competitors come up with the product earlier than the original organization. The other things that we have also seen, not on the breach side of it, but also on the incident side of it, is denial of service. It is quite high when it comes to manufacturing. Now, again, denial of service may not impact their production lines, but obviously they impact their online presence. Now, if I refer to the data as per the data breach investigation report of this year, 2022, what we have seen that system intrusion, basic web application attack, and social engineering have constituted almost close to 88% of the breaches. Now, when we say intrusion, system intrusion, it is something which is a sophisticated kind of an attack. It is majorly, if not every time, but most of the time attributed to the APTs, advanced persistent threat, followed by the basic web application, where basic authentication is missing or lost of stolen credentials, and using those unauthorized access to application, and social engineering, which is largely attributed to phishing. And when it comes to the threat actors, we have seen almost close to more than 85, to be precise, 88% are external, with internal as well. And internal can be error and misuse, or somebody who's totally disgruntled. Foreign industry, where availability, I would say equal productivity, 70% of the incidents are also caused by denial of service. I've already covered denial of service, but why I'm referring it to again, that it may not impact their production lines directly, but they definitely cause availability concerns at the parameter. If I really have to talk about 4 or 5 top threats, I would say ransomware tops the list, followed by intellectual property theft, phishing, use of stolen credentials. Espionage attacks again corresponds to intellectual property theft. One thing again, which is very unique to manufacturing, and they are paying a lot of attention to it, is specifically on the supply chain, because they rely a lot on supply chain, and any kind of a supply chain attack have a very big repercussions with regard to manufacturing. And last but not the least, but because of the Industrial Revolution 4.0, the use of IoT, or I should call it as IIoT, which is Industrial Internet of Things. It definitely gives manufacturing way more advantage in automation and getting real-time data feeds, but it also poses or increases the threat landscape, and they definitely need to look, because we are seeing a bit of more incidents and breaches happening on those components as well, because inherently the OT, which is the operational technology, it's not supposed to be secure, because these are technologies being running for almost 25-30 plus years. So to answer your question in a very concise way, ransomware, phishing, loss of stolen credentials, intellectual property theft, which is majorly attributed to espionage, supply chain attacks, and the IIoT components.
You mentioned about intellectual property, which is something which is the manufacturing industry's key assets and the price position. So what are the steps that you've taken to avoid it?
So we have seen a lot of steps being taken by the manufacturers with regard to protect their intellectual property. Now, one of the major things that we have seen them doing is the network segmentation. Many of the manufacturers rely on segmenting, or what they term that uses air gapped between their OT and IT environment. Now, which in reality, when a check is done, that's not always the case. Because they may have a HMI system, which is human interface system, which is monitoring all the systems like the sensors, the temperature, the pressure within the manufacturing plant. But that HMI system may be connected to internet. So what we have started seeing that the organizations are doing is having this perception that they have an airtight network segmentation. They are validating that. Second thing which we have seen, which is good to see specifically on the manufacturer is that they have started creating the asset inventories, not only to include IT components, but also to include OT components, what hardware, what software they are using, what PLC versions, what serial number, what firmware number, version, and all of the installed components within their environment. They have started doing that. In complementary to the network segmentation part, they have also started reviewing the overall network architecture. Now, one thing that I have seen, which is not something new, but which has been present for a considerable period of time, is a model which is known as the Purdue model, Purdue Enterprise model, which has different levels from level 0 to 6, level 0 to 5. I may not remember all of them, but obviously can recall some of them. Like on a level 0, it talks about the actual physical processes. Like if I take a manufacturing, let's say a water filtration process, that's at level 0. But at level 1, it talks about building a layered security approach for the intelligent sensors, like the pressure gauge, the sensors, the thermometers. The level 2 comes to the control systems, which is something like a remote terminal unit or an RTO. Then at level 3, they comes to control system operations, which is kind of a system which is using all the telemetry data from the remote systems and the monitoring and management of it. At level 4 comes the business application, which is more to do with the ERP, because was the first adoption by the manufacturing processes. And at level 5, it comes the corporate IT network. That is where I have seen manufacturers specifically started following the model and doing things in line with the Purdue model. Also, they have started following the system configuration hardening in line with the industry best practices, which is some of them as NIST, and one of them which is largely used is IEC 62443 model. And not only the IT components, they are including the components like the HMIs, the PLCs, the engineering workstations, the historians, which contains the historical information for data analytics, as well as the industrial networking devices, including the IIoT. The specific framework which I referred is known as PERA, which is PERA, which is Purdue Enterprise Reference Model. That is what we have been seeing a lot of industries, manufacturers are using on segmentation part of it, on ensuring they're following critical hardening guidelines. They are ensuring that the best security practices are being followed. The network segmentation is being followed. And one last but not the least is monitoring for anomalies, which is at the network level, which is a network level monitoring, which is a combination of both, which is at the IT side of it, but at the OT side of it, what reading the sensors are giving. One most important point, which a lot of manufacturers, I would say, started following recently, is the communication that is happening between IT and OT folks. Because it's a different mindset. OT is always about availability. IT is always about confidentiality. And those who are into the cybersecurity domain, if there is a vulnerability, they want to patch. Patching means system downtime. OT folks, they don't give you a system downtime because it's a 24/7 running machinery and it's millions of dollars of losses. In order to make sure that a vulnerability that exists does not impact the entire availability of the production line, they are following these guidelines, limiting the communication between the devices who are vulnerable, putting into a different segmentation, and doing a lot of monitoring for anomalies. So these are some of the steps that I have personally seen, because I've dealt with a lot of manufacturers. We have a lot of customers who are into the manufacturing domain, and these are some of the things that they are following.
Are manufacturers in the process industries more vulnerable to the cyber threats than the discrete manufacturers, and why?
Okay, I would say both are equally impacted. If I talk about the overall manufacturing, if you refer to the Global Intelligence Threat Report of 2021, it has mentioned that manufacturing overall, whether it is process or discrete, has moved from 8th position to 2nd position, and they are just behind the financial and insurance sector as a prime target. The biggest of the malwares that have existed have targeted both of them. The Colonial Pipeline, which we know was hit last year, which is one of the SCADA systems, if not an entire ICS. But around the same time, there was a cyber attack on JBS Foods as well, which is one of the largest manufacturer of meat. But if I really have to pin down First of all, the understanding of the difference, because discrete is the components are built up discrete. A very simple example for discrete manufacturer is an automobile manufacturer, and for process is majorly like who are into product manufacturing, cosmetics, personal healthcare, the FMCGs, and so for them they have a recipe for creating the quantities in bulk. So component A, B, C, D, they come together, mix it, the components get generated. Now, if there is a cyber attack, let's say on one of this component, and if it has, let's say it has to be only put as 10 ml, and somebody increases that volume from 10 ml to 20 ml, the outcome changes drastically. And possibly the qualities goes for a toss. There is a lot of wastage of the product that happens, and that product is may not be able to be, the company may not be able to sell that product, and it has to be thrown possibly in the bin. The thing that possibly may be advantageous to the discrete, their components are built discrete. Take an example of a car. Nuts and bolts are discrete. Car doors discrete. The overall car body discrete. If there is an impact on one, it does not impact the overall component. So obviously they have a bit of advantage, but I would say both of them are equally impacted. They both leveraging the industrial 4.0 by using of IIoT technologies. Their threat landscape has increased. Both of them gets equally impacted. The example that I use for discrete, that since their components are discrete, they may not be impacted, but in order to, when they go into the recovery phase, the cost of labor and the time that they have to spend is also too much. In case of a process, the output has gone screwed. It may not result in a direct labor loss. Yes, there will be a cost loss, there will be a time loss, but in a discrete, then that only that component has to be get rid of, but it obviously requires a lot of labor and cost. So I would say both of them are equally vulnerable, but when it comes to the overall impact, then obviously the process has more because the end product goes for toss. And one terminology which I've been started using, I read it somewhere, I do not know where. I always say the code goes like, the greater the connectivity, greater is the profitability, but greater is the risk, which is the manufacturing is facing now. But I think they are doing good by adopting newer and newer things. We are really started to see the discussions that we have with our manufacturing customers. They really want to go for network architecture review, secure configuration review. They really want to know what is happening, not only in their IT environment, but what is happening on their OT environment. So I hope that answers your question on discrete versus process.
How are robots, conveyors, and other types of automation vulnerable to cyber attacks?
Automation is a direct result of, again, I've been saying this because I've been hearing this a lot in the industrial conferences that I attend, which is called the backbone of the 4.0, which is automation. And automation is getting everywhere because it gives the advantage to improvise the process, faster to market, good quantity, good quality. But the components, specifically like you, I think, mentioned conveyors and robots. Now, conveyors basically comes under, if I talk about the entire manufacturing process, it comes under the material handling system. Taking an example of an ASRS system, which is an automated storage and retrieval system, which is to retrieve and store component automatically. Now, these are not a single component. They are a combination of component. It calls a kind of an ecosystem. I take an example of a robot. A robot is an ecosystem. It requires a physical robot. It requires a software. It requires an operating system. It requires software. It requires firmware. It definitely will have mobile or applications which can be controlled remotely. It may have a kind of an access to a third-party vendor for management purposes. It may have the data from these robots directly going into the cloud for big data analytics and taking intelligent decision. So the cloud will come into picture. Now, what we are seeing is the threat landscape is increasing. Some of the things that we have seen with the challenges that were faced with automation, I'll call it as automation, because whether it is conveyors or whether it is robots or whether it is ASRS, there are certain things which are at the crux of these problems. Because number one, which I have personally seen, and we have discussed that in the industry, is insecure communication. Because these are not built with security in mind, most of the communication, like the telemetry data that flow back and forth, it is either unclear or it is not encrypted with a very high level of encryption, and most of the transfer of this data happen over Wi-Fi networks. So it is susceptible to eavesdropping. The other issues that we have seen is some of the services are not authenticated, specifically with regard to robots. And it has been proven in the past that how these robots or self-driven cars have been compromised because some of the services which are critical are not authenticated. And some adversary is able to compromise that service or even able to bypass a basic level of authentication that has been built. Privacy concerns, I'll not go into the details of privacy, but those concern has been there. One of the major thing is weak or default configuration. Not directly to manufacturing, but there was one of our customer who had their entire IoT infrastructure getting compromised because of weak configuration, because they were using username and passwords. All of them are default. So they have smart cameras, they have smart street lamps, everything as a smart campus, but everything running with a default credentials. And they were the target of a Mirai botnet attack. And those all compromised systems were used to target other systems. So obviously, yes, automation helps, but it actually increases the overall threat landscape for the manufacturing industry. So some of the steps that we mentioned in question number 2, proper network segmentation, ensuring security-based hardening being employed, are some of the things that manufacturers are actually working. It is not, I will not say they should, but I've seen they are already working towards this to address the issues with regard to automation as well.
What are the leading manufacturers? How are the leading manufacturers tackling plant floor cybersecurity issues today?
So I think plant floor again goes to majorly to do with OT components, and partially I think I've answered this question in question number 2. But the older ICS system that have been operating for almost 25 plus years, they have a lot of legacy components to it. And as I mentioned, their priorities is high performance. Their priority is availability. Their priority is not on confidentiality. So some of the things that they are definitely doing, as I mentioned, is documenting the network communication. What protocols are being used? Other thing that they have been doing is a proper communication channel being established between OT and IT folks. Because if I really speak to some of the cybersecurity experts, they may not understand some of the protocols that is being talked about in ICS network. Like some of them I can recall is DNP3, Modbus, BACnet. They don't understand that. So some of the things that have been started happening is the OT folks transferring that knowledge to IT folks, that these are some of the main protocol components that are being used, and they need to understand that. The second part, as I mentioned, a lot of focus being paid even at the plant level to engineering workstations, to HMI systems, because at the root, they are many of them are working either built on Windows operating systems or Linux operating systems. So one of the things that have been focused on, that at least the operating system level vulnerabilities can be taken care of. And then obviously the most important part is the segmentation, which is happening at the PLC level. We are seeing the interface are being understood way better than what it used to be. And the IIoT sensors that have been deployed, patching may not be that rigid, but the focus is on patching now. So as I mentioned, proper network segmentation, that A, B, C components. A, yes, we can patch it on a regular basis. B, we may not be able to patch it on a regular basis, but we can patch it like once in 3 months or once in 4 months. And one, which is the core ICS systems built 25, 30 years ago. We do not know whether if you put a patch, what will happen. If you need a restart, we may not be able to do it. So doing that airtight gap within even the plants as well is what we have been seeing are being employed even at the plant level.
One of the major issue is the skill gap. What's your view, and how can we tackle this?
So obviously one answer to the skill gap is skill-based awareness and skill-based training. I mentioned to you that first of all, the mindset needs to be changed, because I have seen a constant fight. Then we get into breach investigations, and sometimes if it happens to be in the manufacturing plant, we do have IT folks, we get OT folks, but we have often seen a kind of a gap in understanding each other's priority. Their IT folks or cybersecurity folks are very majorly threat and vulnerability focused. OT folks are majorly very well focused on the availability part of it. So one thing is to make each other understand that how both of them have to come together to basically take care of this skill gap. equal amount of training. OT understands IT perspective, IT understands OT perspective, because we do not have an option anymore that whether we should do collaboration. It is a necessity. It is a necessary evil, I would say, of a collaboration between IT and OT. It has been long talked about whether that collaboration should be done or not, but it has been done. On the scale side, now we have trainings and courses available for cybersecurity professionals, which are very much focused to ICS SCADA systems, that they understand the basic fundamentals of ICS and SCADA. What are the key component? What is an RT? What is a PLC? And how they can be specifically impacted. Skill-based training is definitely one thing to take care of that the corresponding skill gap. And yes, the proper collaboration between OT and IT, so that both of them understand each other's perspective, and it is not the case that anyone is trying to put his feet on somebody else's foot. So these are the couple of things that can be done to take care of the skill gap. But yeah, I'm very happy to see in the past 3-4 years. In fact, I have looked at a lot of courses and trainings with regard to ICS SCADA systems, which help me understand the perspective when I speak who is hardcore manufacturing OT person working in a factory, working at a, understand their perspective and helps me understand. So it is no more awareness of a stuff. It is more has to be a skill-based training, and it has to be both from the both sides. It is not only the cybersecurity professionals have to understand it, but it is also the OT people who have to understand it. That why we are talking so much about threat and vulnerabilities, and what can be the repercussions. Some of the things that organizations are also doing is bringing both the OT and IoT people together as a part of a cybersecurity program, possibly being headed by a CISO, but the responsibilities has been percolated, some of them to the R&D department, some of them to the process owners. What they are trying to do is first doing the capability maturity assessment, that where are we at IT and OT security. Then establishing governance structure, which is very important, where I mentioned there is still a gap between understanding of IT versus OT. So proper governance structure is being put, so each one of them understands each of the responsibilities. Then based on the outcome of that maturity assessment, assigning the risk, and then formally building a overall security and building controls, preventive, detective, anomaly detection.
Thanks, Anshuman. Thank you for your time, and thank you for giving us the insights on what are the cybersecurity challenges for manufacturing that manufacturing is facing today. Thank you.